Hello, welcome to today's lesson. Today I want us to look at cyclic quadrilaterals. Cyclic quadrilaterals. Now, a cyclic quadrilateral is a quadrilateral whose vertices lies on the circumference of a circle. So all the four vertices must be on the circumference of the circle. So in other words, this is a cyclic quadrilateral ABCD. Right. So but then we need to make sure that all the four vertices are on the circumference of the circle. So in other words, if we have something like this. Now, this is a quadrilateral, but it is not a cyclic quadrilateral because you see this vertex here, it's not on the circle. So we need to make sure that all the four vertices lie on the circle. So that will be a cyclic quadrilateral. So this here, PQRS, is not a cyclic quad. Right, so we need to understand. So it must be inside the circle. All the four, like we have our A, B, C, D here, it's a cyclic quadrilateral because all the four vertices lie on the circumference of the circle. Right, so now we are going to look at the theorem about cyclic quadrilaterals. So the first one that I want us to look at is that the opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. Note that this theorem, you may be asked to complete it. So they may give you these words. They may say to you, complete. The opposite angles of a cyclic quadrilateral are, so be careful not to say equal, because don't be tempted to say equal. They are not necessarily equal, but they are supplementary. Now, supplementary means they add up to 180 degrees. So this is the meaning of supplementary. So supplementary angles are those angles that add up to 180 degrees. So remember, those that add up to 90 degrees, we say they are complementary angles. And those that add up to 360 degrees, we say they are revolutionary angles. So if they add up to 180, then we say they are supplementary angles. Right, so likewise, we are going to have, let's have a cyclic quadrilateral. Let's have a cyclic quadrilateral. Right, so let's have a center. So we say we have a cyclic quadrilateral ABCD and with a center O. Right, so we need to prove that the opposite angles, now the angles which are opposite is angle D and angle B are opposite, or angle A and angle C are opposite. So we are going to prove either pair here. So let's prove, we are required to prove that angle A plus angle C equals to 180 degrees. Right, so this is what we are required to prove, that angle A and angle C plus angle C, it's 180 degrees. Right, likewise, we have to do construction. So here we are going to join DO and OB. DO and OB. We join DO and OB. So we join DO and also OB. We join DO and OB. So now we have O1 and O2. Right, we should notice that here, because we are proving A plus C to be 180, we are joining DO and OB. If we were proving that D plus B is 180, then we will join AO and OC. So we need to notice that. So we start proving. The first statement that we can say is that angle O1 equals to twice angle A. Angle O1 is twice an angle A. We can see it's an angle at the center theorem. We are applying the angle at the center theorem. Right, so if we continue with this, we realize also that angle O2, it's also twice angle C, same reason as above, so it's the angle at the center theorem. Right, now we can conclude from this that therefore twice angle A plus twice angle C is the same as O1 plus O2. What we do on the left, we also do on the right. But we actually know the size of O1 plus O2. We know the size of angle O1 plus O2. Angle O1 plus O2, you see these are angles around a point. So we know that when we add them, they give us 360 degrees. So these are angles around a point, or what we call revolutionary angles. So now we can substitute the size of O1 plus O2 on this statement. So we can put O1 and O2 as 360, meaning 2A plus 2C, it's actually 360 degrees. And then when we divide throughout by 2, we will have angle A plus angle C, which is 360 divided by 2, which is 180 degrees. Right, so this concludes the proof of our theorem. Remember, we were required to prove that angle A plus angle C is 180, and we have just proved here that angle A plus angle C is 180. So the final statement is the same as the required to prove, and therefore we have proved the theorem. Thank you. Please don't forget to subscribe, like, and share. Thank you very much.